Bismillahir Rahmanir Rahim. Welcome to Cambridge Maths. Today we are going to solve a question from Probability and Statistics 1, and the question belong to paper 9709/52 for the session May June 24. We are going to solve the last of all questions of the paper, question number 7. Let's read question number 7. 7 says, how many different arrangements are there of the 10 letters in the word regenerate? So, this is well known to us that for arrangements we apply the concept of the permutation. That's why we can simply write number of total arrangements. For the arrangements we apply the concept of permutation. As there are 10 letters, so it will be 10 factorial ways. 10 factorial ways, or you can tell 10p10. Let me write it as 10p10. You may tell that 10p10. Then these will be total arrangement will be divided by the factorial of the repeated or identical letters. Look at this. Among these the letters of regenerate, here there are 4 is, so we will divide it by 4 factorial. At the same time there are 2 r's also, so we'll have to divide it by 2 factorials. This is actually nothing but 10 factorial over equal to 10 factorial over 2 factorial into 4 factorial ways. So 10p10 means 10 factorial. So what have we learned from this question? That for arrangement, if the question asks for arrangements, we will simply apply the concept of the permutation. So there are 10 letters, that's why in 10 factorial ways they can be arranged. And for identical or same letter or repeated letter, we will divide by the factorial of their numbers. So there are 2 r's, that's why we have divided by 2 factorial, as well as there are 4 e's identical, that's why we have divided by 4 factorial ways. Now if we divide 10 factorial by 2 factorial means 2 4 factorial means 24. So 10 factorial divided by 48 is equal to 75,600 ways. So this is our final answer. This is our final answer. That means 75,600 ways these 10 letters can be arranged. Let's see the immediate next question. How many different arrangements are there of the 10 letters in the word regenerate in which the 4 E's are together and the 2 R's have exactly 3 letters in between them? So let's write the scenario. First of all, we are going to write here. Look. So they have told 4 E's are together. Okay. 4 E's are together. So 1E, 2, 3, 4. These are the 4 A's which are together. Well, then they have told that there will be 2 R's in between which R and R. In between 2 R's there will be exactly 3 letters. Exactly 3 letters. So this should not be R. There will be 3 letters in between them. So 3 spaces, and then there is R. So there are 4 E's together and 3 letters in between R. Let's see how many are left. So total 4, 4 to 6, 6, 3, 9. So one more letter is still left to be arranged. Now, what is the scenario? We can look at this. 4 is can be one unit. So we can keep it in one box. And the second box is these R's and having three letters in between them. And the last of all, there is another box which contains only one letter. So this is our scenario. So how can we write it? Now we will write number of arrangements. Number of arrangements is equal to. First of all, look at this. We have divided or split all of the letters accordingly in three different groups. One group, two groups, three groups. So these three groups can interchange their position. That's why, first of all, there will be three factorial ways they can be arranged. After that, let's see these three, this one, as well as this one. These four letters can interchange their position in between them. So we can write this in one, two, three. So into four different ways. Four different ways they can be arranged into four factorial ways. So that's all about the arrangement, because look at this, we have arranged all possible cases. And you may ask about the you may ask a question about is are actually, if they replace each other, actually it's all the same because they are identical. So is for R also, they are identical. So for identical cases, there is no question of arrangement, they will remain all the same. So these are the only cases. So if we find the number of arrangements, 3 factorial means 6 and 4 factorial means 24. So 6 24s are 144. Only there are 144 ways to arrange the letters according to the situation. I think all of you have understood this, one of these two of the simple solutions. So this is what the solution to question number B. Let's move on to question number C. That is on the next page, page number 13. Okay. Let's see what the question says. The question says, find the probability that a randomly chosen arrangements, still arrangement, that means we are going to apply the concept of permutation. Arrangement of the 10 letters in the word regenerate is one in which the consonant G, N, R, R, T and vowels A, E, 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 E alternate, so that no two consonants are next to each other and no two vowels are next to each other. So let us write the scenario first. Suppose first one is consonant. Okay. Then there will be space consonant, consonant, consonant. So 1, 2, 3, 4 and 5. These are the consonants, consonants, consonant, consonant, and in between them there will be vowel. Okay. So there are 5 consonant as well as 5 vowels. Let us symbolize the vowels with different inks. So this is vowel, this is vowel, this is vowel, as well as this is. Then one more space is left for vowel because there are 5 vowels. This is also vowels. So this is the scenario that no consonant, neither any of the consonant nor any of the vowels can stay beside each other. They cannot be together at all. So what is the possible cases? Look at this. This is also arrangement. So we can write number of arrangements. Number of arrangements, and we know that number of arrangements is done applying the concept of permutations, equal to. Okay. So there are 5 vowels. For 5 vowels it will be 5p5 means 5 factorial, 5p5 or 5 factorial are same. Then among these 5 vowels, look at this, there are 4 is. So for identical letters we will divide it by 4. Now this was about vowel. Now what about consonant? There are five consonants as well. Five consonants. Out of five consonants, there are only two R's identical. So we will divide it by two. So these are the cases, possible cases of arrangements. Now let's see what can be the more possibilities. Look, C can replace V. Each each C can replace V, or each V can replace C. It may happen everywhere. Okay, so there is the possibility of one more cases. That means the same scenario can be alternated. That means one more cases can happen in this case. That means we will have to multiply by 2, because there are two such cases. Into 2 or 2 factorial, whatever you tell. 2 and 2 factorials are same. That is right. 2 factorial ways. That means each of the vowel can each of the vowel can replace each of the consonant. So ultimately our number of arrangements is going to be, what is it going to be? 5 factorial means 120. So 124 factorial means 24. So this is going to be 5. Well, and 5 factorial means 120. 2 factorial means 2. So 120 into divided by 2, that is 60. Well, 60 into 2 factorial means 2. So finally we have got 300. It's 600. 600 different ways the the consonants and the vowels can be arranged. Well, we should not forget that the question has told us not to find the number of arrangement. They have told us to find the probability. So probability is just simply we will divide these arrangements by the total number of arrangements. So we can write the probability is equal to probability. Hence probability is equal to probability is equal to probability is equal to these arrangements. It's 600. Then we will find what was the total number of arrangements without any restriction. Without any restriction, the number of arrangements was, look at this, this was the number of total arrangements, 75,600, without any restrictions. So total number of arrangements is 75,000. It is 75,600. 75,600. Well, now if we divide 600 by 6 by 756, it is going to be 0.00.793 793.6. So if we round it up to three significant figure, it is going to be, it, it tends to 0.00794. So this is what the total number, this is what the probability of this question is. So that's all about this, one of the simplest and easiest of all questions of probability. The first solution is over here. This is the solution to A and B, and the solution to C is on the next page. This is what the solution to question number C. So thank you all for being with me. Let's talk with each other in the next video, inshallah. Fi amanillah.